So I'm a peer. Hopefully most of you are also peers. But I would like to kick it off with this story. How did I got interested in the team of peer-to-peer? A few years ago, I was with a friend, and he was next to me. And for some reason, I sent him a Facebook message. And I sent a picture, and I realized that something's wrong with the web. Like, this message had to travel thousands of kilometers to get to a server and get back to him. But like, why doesn't it just go instantly to him? And I started to think about, how can we change this? How can we make this better? So after I found that, it was basically what I've been looking for. So probably we all know that we use HTTP mostly in the web, and it uses this client-server model, which means that every computer in the network is defined by its class, which can be client or server. Basically, everyone's a client, but some of us are servers. And I think this is the major problem in most problems we face on the web, basically surveillance capitalism or centralized networks and platforms, because this protocol is a bit misdesigned for these things. It's basically, there's too much friction in publishing because you need to understand how servers work, how to set up a server, and this shouldn't be like this. And as Yannick mentioned, and I think this whole event is not about saying that HTTP is wrong and it shouldn't be used. It just should be used for something else and not everything right now, because we use HTTP as the default, and I think that should be changed, because HTTP is awesome when you really need a trusted computer, but not for everything, like small websites. And yeah, this is a pretty common illustration of networks. The centralized networks are basically what we use mostly, and as you can see, if you remove the central point, the network won't exist anymore, so it's not so strong. Then there are decentralized networks, I would skip that. And the distributed networks are what I think most technologies here talk about. They're the peer-to-peer ones, where you connect straight to your friends, and if you remove any point, a random point from that network, the network would still exist. So it's really powerful and a really stable network. And this is a quote from a workshop of basically the developers of the DAT protocol. Basically, a peer in a decentralized network is an equal authority. So basically, we're all equal in a peer-to-peer network. You have the same right to write and to read the network, which is very powerful, and it's not the common case currently. So basically, the server and the client are the two same things, which basically we don't need the word server client, and that's why everyone's a peer on a peer-to-peer network. So you have the same rights, you have the same tools as a server and as a client. And basically, the peer-to-peer web is a browser that includes these protocols. So there's this protocol and project called DAT, which was developed for researchers to share big data between each other. And it's basically just a file sharing protocol. So it's very similar to this protocol if you used it in your browser, hopefully yes. It just makes files or directories open from your computer to everyone. And this is the difference between simply the file, that other people can also view these files and get them, edit them, where they can't really edit them directly, but in a way, yes. So Paul Frazee, he's the main developer behind Beaker browser that you will hear a bit later, says that the peer-to-peer web embodies three principles. First of all, anybody can be a server. As I said, you can publish just as you can read. Multiple computers can serve the same site. This is how basically torrent works. So you contribute to the same archive. Your computer can have the same archive as the server has. And this is also true in the reverse. So multiple sites can be served from the same computer, which is kind of the case in HTTP, but it's pretty much a struggle to host multiple sites from one computer. And there's no backend, so on the peer-to-peer web, you don't have separate backend and front-end code. There's only one code that runs everything in the browser. And that's also very powerful, and You have to design applications very differently if you keep this in mind. So Paul Frazee also says that if you integrate these into a browser, it will let users publish independently and move between applications. So you don't need to set up a server, you don't need to own a server and pay for domain name or the SSL connection. You can just simply host it from your computer. And I think if we remove this huge friction from web publishing, it would enable for a lot of people to share their work on the internet, because the internet is awesome and everyone should share their stuff. So on the peer-to-peer web has a lot of pros, because yeah, we are pretty excited about. So it cannot be shut down. There's no centralized service or authority. Basically, you don't need anyone to make a peer-to-peer network. It works very well offline. I'll talk about this a bit later. Scales very well. So if you run a website, you know that more users mean a lot of bandwidth and more traffic. And that's a huge problem, because you need to pay more, you need to run better computers. This is not a problem on the peer-to-peer web, because more users mean more peers. So they share your bandwidth, they share your connectivity with other people. And authentication is not required. This is a topic I really like to think about and mention, because you don't have user accounts on the peer-to-peer web. You don't need to log in, you don't need to register. This protocol basically can decide if you're the owner of something or you're just a user of something. And I think this is very powerful and can make applications a lot smoothly included in your life. But also, there are a few cons. And basically the first one is what I think most people are mentioning, that if the site doesn't have peers, it's not available for anyone. And this can be solved, but yeah, this is a major problem, but this is also the beauty of the peer-to-peer web. We'll talk about also how to solve this later. Your computer is open to strangers. That's an issue for a few people. Basically, they directly access the files from your computer, which you might not want to. And there's no really way to solve this. And you must trust your peers. So this isn't as stable or as secure as the HTTP, in a way that right now I think only kind people are in these networks, so you don't need to be careful with it. But if some bad guys will also join and they share something that you don't know what's happening there, they can write basically to your archive and they can modify things. It's not so true for viruses, but yeah, I think we should keep this in mind, that you must trust your peers. And this is when we arrive to Beaker browser, which is a web browser that includes this DAT protocol. This is Beaker, what you can see here. And it's basically just like any other browser. It also supports the normal HTTP protocol. It has a few differences in the interface. For example, there's this number here, which is your peer count. That means how many seeders does this archive that you're correctly connected to have. And you can also choose to seed the site, which basically means that it will be downloaded to your computer, and you can access it offline too, which is a very powerful thing on the peer-to-peer web, is that we also have this topic in HTTP, that offline first, and that it's getting more and more common, but that's not really truly offline first. In Beaker browser and in peer-to-peer web, this is just 100% offline first. I think that's my next slide. Yeah. So it's 100% offline first. When you decide to see the site, it will be available, all of the content and everything on your machine, so you can basically visit it anytime without internet connection. As a publishing standpoint, it's like no man's land for sites. You can imagine just a field, and you walk around it, and you see that I want to grow flower on that piece of land. And you don't need anyone to say that, yes, you can do that, or you need to buy that, because there's so much space on the internet. We don't need authorities for that. So you can just publish what you want, publish as much as you want, and you don't need to depend on IP addresses or computers. just basically these dat keys, which will automatically generated. So applications on the peer-to-peer web are a bit different as a designer standpoint, like application designer standpoint, and as a user standpoint. First of all, they don't use a centralized database or user accounts, so you don't need to register, you don't need to save all your data to a database. Everything is happening on your computer. Also, yeah, all the data you use is stored locally in your file system. If you use an application, it's basically just writing to your file system and never save something. Basically, data never leaves your computer. And how you basically, you just give them read or write access to that one single archive, and that's how you use tools, basically. So if you would imagine one change on a normal web, that would be basically one request when you get the data, then one request when you set the data, then you get the data back, that's another request. On a peer-to-peer web, this is just one thing. Basically, you say for the application that you want to change this, and it just writes it to your file system. So you don't need request, it's just instantly happening and in real time without any data leaving your computer or stored somewhere else. And this way, basically, platforms become only tools, which is very powerful because you don't need to depend on the platform. You can just simply have some files on your computer and use tools to change them or visualize them. And yeah, from now I would basically show you a few examples of real-world applications in a progressive way. The simplest is Antane. I made this just as a little hack when I found the peer-to-peer web. Oh, I have it open. So Antane is just a file sharing application. It's like Dropbox, but for your computer, and it's very dumb because I spent like few hours making it, but it was the first thing I made, and it was very exciting that you can do these kind of things so simply. So if you want to share some files from your computer, you just basically drag them in, and if you send this link to anyone, they can download this or view this. And it was just very powerful to see that so simply you can make these applications that you would need to use platforms for it. So that was Antane, and there's this application called Dropout. It was made by John Kyle. He has some pretty nice applications on peer-to-peer web, and it's just a pretty good example of an application that you can use for yourself, and you don't want to publish, you don't want to do anything special, just use an application for yourself. Dropout is basically like Pocket, but only on your computer, so you can save links to it, add links to it, and they will be saved on your computer. And you can view them. As I'm not the owner of this site, as I said, the protocol can decide if I'm the owner or not. I'm not the owner of this site, but I will make a clone if it's not a problem, Raphael. So I can make a copy of any site, basically. And now this is my site, so from now on I can edit this site and add to it. And basically you can just put a link here and it will be saved to your computer and you can access it offline. So I think this is a very nice example of how simply you can use applications, and not just for publishing, but for your own usage. Yeah, here's the link if you want to try it out. Then I made these two little things called Oracle and Solo. They're publishing tools, and they're mostly just, I really like this idea, as I said, that you don't need to authenticate on the peer-to-peer web. So I like this idea of an interface that reacts to its owner and to just users. So as you can see, I'm not the owner of this site, so I can basically read the entries and navigate the site, but if I fork it, yeah, there's this make editable copy button in Beaker that you can basically fork any site you want and have your own version of it. So if I visit my site now, as you can see, on the interface changes a bit, and you have this little write your first entry button, and you can also delete or edit entries or customize. And I think it's very cool that you just don't need to log in or go to a panel or an admin page. You can just simply go to your site as other users go and edit them. And Solo is a bit a stripped down version of this, and it also works like this. So if you are the owner, you can edit the text in the Oracle, and if you're just a normal guy who visits it, you can just read it. So there's Roton, which hopefully I pronounced that correctly. I think it's French. So is it French? I think I met Yannick there on Roton. Okay, yeah. So it was made by this cool guy called Devin Lulimvega. And it was a social network. It's not really used now because that is not the perfect protocol for social networks. You will hear about one later. But that is very simple. It's still a tool. It's not a platform, because all the data that you have is just a file on your computer. And how you follow other people is by linking their URLs or pasting them into a field. And from after that, basically, when you go to Roton, it just gets their file and presents it on your feed in a beautiful way. And it was a very nice example of how easily you can connect to other people and how simple technologies like files can be used for social networks. And that's how I got actually introduced to this whole that thing and peer-to-peer web. So, and I think this is the most complicated and most complex content management system on the peer-to-peer web. It's called Inoki. It was also made by John Kyle. And it's basically like every other content management system on the normal web, but it uses your computers. Oh, and it's, yeah, I think you have a wrong site in it. No problem. So it has this panel. Okay. Yeah, it's a bit buggy. So it has this panel site where you can edit a site if you want, you can create a new site if you want, and it's just playing with the files on your system. So it's that simple. And you can use that to, for another site, visit it. And as I said, it's not leaving your computer. Your files are on just the panel directly writes to your file system. And it's very powerful when you think about that. You can edit offline and synchronize whenever you come back online. There's this cool example, and it's a very good solution for this bandwidth problem. Hypercast is a streaming application. You can stream from your computer, and people can watch it in Beaker browser. Because when you're streaming, you can get pretty high bandwidth, and this way it's solved because all the viewers basically help you share the stream with other people. So your bandwidth won't be as high as in the normal seeding service or streaming service. And as I mentioned, there's this availability problem. When there are no peers, the site is not available. There are a few ways to deal with this. There are services for this, and or you can just run it for yourself, which is Cedar, a project with New Computers Working Group. We designed a little plug-and-play Raspberry Pi Cedar. So you basically set up a Raspberry Pi and run a script, a one-liner script, and it will set up your Pi as a Cedar where you can go and just add that URLs, and it's like an always-on user on the network. So you just need to run the Raspberry Pi, and the site will be available for everyone. You don't need to run your computer, and it's not depending on your availability anymore. There's also Hbase, which is, I think, the most common way to do this. It's a service that does the same, seeds your site forever. And there's also some new stuff happening, like Cabal. It's basically like Slack in a peer-to-peer way. It's a peer-to-peer messaging application. You can make new instances of Cabal just with one click, and you can share that with other people. And you have all the messages on your computer loaded on your computer, so you can view them, and even you can write messages while offline, and they will be synchronized when you come back online. So it's pretty nice, and it's pretty new. So that was and the past, what's happening. Currently, I think about and design tools for problems that make that more available for the normal people. So we try to progressively introduce this technology into people's life, because I think the problem with these blockchain networks and Ethereum, for example, is that they're not compatible with the existing solutions. So, or an app can run in Ethereum, or it can run in the normal network. With that, that's not a problem. You can still use HTTP as a fallback if that is not available. So you can just slowly, step by step, introduce this pretty awesome and pretty powerful technology into the normal people's life. And there's this other project I'm working on with a guy, Alexander Zeng, I think I pronounced it correctly. It's just exploring some ways how can we make these shared spaces on the internet or on the peer-to-peer web. Soundscape is like a radio where any user can add to a song to the network, and it's all peer-to-peer. So it's basically just a shared space where you can go and hang out, and if you want, you can add some songs. It's pretty buggy, but we're working on it to make it more stable, and hopefully we'll publish it sometime. And basically what I do is make any tools I need. I can use Beaker for basically anything I need to use. If I need a note-taking application, I can use Beaker. So I think it's a very good universe where you can make tools or use tools for yourself and not just for publishing. And I actually really enjoy this aspect of the protocol, not just you can freely publish and freely use the apps, but also that you can just use apps for yourself, basically. So you may ask, is this production ready? Can we use this in real? And there's this pretty long quote that's, yes, actually researchers use it, other projects use it, so it's really ready for production. It just needs to be introduced somehow for the people that it's worth exploring because it has some possibilities in it. And as Yannick mentioned, we don't say that this is the future. We don't say that this will change how we use the internet, or maybe it won't, maybe it disappears. We don't care, because I think it changes the way you experience the web. So it changes the way you use the web currently and how you can use, because if we have more events like this, you realize that, yes, I don't need to use platform for everything because there are some other solutions where I can stay independent. So why is this ambient? This is Brian Eno's quote from Ambient Music. It must be as ignorable as it is interesting. Well, the web is pretty interesting. We just need to make it ignorable somehow, which is pretty hard nowadays. We depend on internet connection. And this is a quote that I really like from André Staltz. How can we make the web work independently from the internet? And I think this is the real goal of that you don't need internet connection. You can have small networks on a local network and still have a web that works for you and works for other people. And I would close it with this question. Just think about it, and even realize that web and internet aren't the same things. And if you have questions, I'm sure you have, because I'm very bad at explaining. At the debate, I think you can ask it. And all the resources are on an Arena channel if you want to look at them. And thank you.